You hear me?
Yep, coming through loud and clear.
All right, perfect. Very, very good. All right, well, welcome everybody to the webinar. Like Dave said, we're going to be talking about faster turnarounds. Basically how to get in, scan, make a model, and turn around that data in a hurry, particularly for schedule-driven industrial projects. And then along the way, we're going to be hopefully laying out in very clear terms what the value proposition is for scanning early on in the whole process. So it should be a great webinar. We've got some great presenters here. And there we go. So like Dave said, my name is Kevin Williams. I'm the chief scientist at ClearEdge 3D, and I love all things point cloud. Today we're going to be I'm going to be your host, so I'm going to be setting the ground rules, giving you a little bit of context for our presenters, and then I'll be introducing them and letting them basically run the show. Our first presenter today is going to be Ryan Hacker, talking about a water treatment plant project that he did. And then next up will be John Garner, talking about a coal-fired power plant project. And then hopefully we'll have some time at the end of this webinar to pick the brains of these guys and ask them some questions about, how they do their work, some of the technical details, really pull some good information out of them. All right, so basically, let me lay out some real quick housekeeping rules. Everybody's going to be muted during the presentation, so just be the presenter who has the floor. However, we want to make this as interactive as possible. So please, as questions come to your mind, as if they say something interesting, feel free to, at that moment, go ahead and type in a question into the chat window of the GoToMeeting session or GoToWebinar session. And it's important to do that as quickly as possible because we always end up with more questions than we can handle, and so we're going to be doing them in largely a first come first serve type of order here. So if you have a question that you are dying to ask these guys, please just type it in as soon as you think of it into the chat window. And we will be taking all those questions at the end of the session. So we will wait. Well, I'm not going to interrupt our presenters. We will wait to the end of the session to ask all those questions. This webinar is being recorded, and you'll each receive a recorded link, a link to the recording after the webinar. All right, so let me set the context real quick for the two presentations today. I'm assuming that most of you in the audience are very familiar with laser scanning and the value proposition that it has for people. And so what I'd really like for you to get out of this webinar, one of the main points is how to better align your services to plant owners' needs, and basically how to sell your services better into those environments, and how to help plant owners understand the value that laser scanning can bring to what they do. So in talking to our presenters, we've kind of distilled out three major needs of an owner-operator and what they need to do, what they can use laser scanning for to better assist their processes. One is minimizing downtime in a plant. A lot of these larger plants are processing tens of thousands, hundreds of thousands, sometimes in the larger plants even millions of dollars of product every minute. So downtime is extremely expensive for these guys. They want to minimize that as much as possible. And the value that laser scanning brings to this whole process is it's able to quickly and accurately create as-built data and allow these guys to plan their downtimes much more efficiently and really minimize that downtime. Another major concern is not just in minimizing that downtime, but minimizing the uncertainty and risk associated with that downtime. Because unforeseen problems can really dramatically compound the costs of any downtime issue that they need to have. So if you can use that as-built data from the laser scanning process to figure out the clearances, figure out ahead of time the sequencing. You can prevent injuries during the process. All these are the types of things that you can do with laser scanning that can really facilitate, really pull out, remove as much of that risk of the downtime process as possible. And then finally, the laser scanning services and the creation of those 3D as-built models can really facilitate the maintenance processes, the scheduling of maintenance for these large plants, because improperly timed disruptions can be very, very expensive. And so the intelligent 3D models that you're able to create based off of laser scan data can really facilitate, they form the backbone for these types of facilities maintenance models that a lot of owner-operators try to use. So with that, let me introduce our first speaker, and that's Ryan Hacker with TruePoint Laser Scanning. Ryan, can you please give just a short introduction of let the audience know a little bit about your background.
Sure. TruePoint, I started TruePoint about 5 years ago. We are a sole provider of laser scanning services. However, we are technically a registered engineering firm in the state of Ohio. But as I mentioned, our sole focus is on the laser scanning side.
All right, fantastic. And with that, I'm going to just let you take it away with your presentation.
Awesome, thank you. So kind of touching on what he was just talking about here, you know, the sooner you get laser scanning involved in a project, truly the more value that we feel our clients are going to get out of the data. And when I talk about that, I actually even go so far as that scanning should get involved actually even before the RFP goes out for whatever work it is at the facility. The idea here is if you could do laser scanning and provide this information to the contractors that will be bidding on the work, they're going to have much better information up front so they can give tighter bids. There's a lot of the unknowns associated with that are going to be reduced. And also, you're able to utilize this data just throughout the life cycle. There is a tendency to get laser scanning involved, usually when there's a problem like the one on the screen here, when you start realizing, okay, we've got an issue. And you know, one of the challenges there is up front, people don't necessarily want to spend the money on it because they're not sure of what value or benefit they're going to get out of it. Unfortunately, the only way to truly understand that value is 20/20 hindsight, and you know, that's unfortunately too late. Not too late, but you've already lost some of your potential value in the laser scan data. We are seeing that change quite a bit, but one of the things that I would challenge is that direct owners and operators really drive this process, as I mentioned, before the bidding process even starts. And if they take ownership of this, you know, they will reduce their own cost associated with the project. So with that, I'd like to jump into talking a little bit about one particular project here. And go ahead, you can go back forward to the next slide there. Basically, I guess a little introduction here. We already talked a little bit. We, again, are a sole laser scanning provider. We do have our own in-house team of engineers, architects, and of course CAD technicians that do all of our post-processing work. We certainly take advantage of Edgewise, which we're going to show you here in just a little bit as well. So with that, introduce you here to the project. As we talked about, we're going to do the water treatment plant. The project was located here in Toledo, Ohio, which is where our corporate headquarters is. We are a nationwide firm with our scan technicians spread around the country, but our corporate office is in Toledo, and that is where all of our engineers and architects are located that work on the post-field work side. So anyway, with that, the challenges of this particular project is you've got a water treatment plant built in the early 1900s. They've added on and done changes, revisions, all sorts of stuff to this plant over time, and really had no good as-built drawings. So they've got a large project coming up that they knew they needed to have good as-builds for, and so that was the whole premise of this project, was to get it scanned. They did end up wanting a 3D model for this to give to their contractors and those associated with the project. So we did end up scanning the entire sub-level here, as you'll see in just a moment. The plant produces about 120 million gallons per day. They're actually doing a pretty sizable expansion to this facility. Most of that was coming to the sub-level areas of the site, and so that was where the scanning was focused on. We did provide, in this case, a level 350 to 400 model, depending on the areas that the client was interested. And we'll show you kind of what that LOD looks like here in just a couple minutes. And then one of the important things here to note is that we did tie this to survey control. We will talk about that a little bit more as to why and how that comes into play. But one of the things that I'll mention with that is that gives them the ability to have us or other providers come in, do additional scanning, and tie it into the same data set, or if they do renovations in a particular area, if they want us to come back after that and do another as-is model, we can also do that being tied to survey control. So some of the the challenges faced here with which is not unusual to large projects. First of all, laser scanning is limited to line of sight. As most of you who are familiar with this would understand, we move the scanner around from location to location to deal with some of those lines of sight issues. This particular facility was no different. There were areas where some were confined space, some are trenches that you can't get down into, different things like that, where we were trying to get as much coverage of the entire site as we could. And you have to deal with some of that. Accessibility, same thing. You're dealing with trying to get into certain areas. Certainly there was construction and operations going on, so having to coordinate with some of that becomes a challenge on a project like this. And then just lastly, it's a large, complex, and congested site, so there are just challenges with maneuvering a site like that. So some of the ways we deal with that come into the workflow that we'll talk about here in just a moment. We do utilize Leica scanners. They are survey grade scanners. We prefer those machines for a lot of those reasons. One of which is the ability to occupy survey control, which again was very important to us on this particular project. We did use multiple workflows actually on this project, depending on the areas we were in, and we'll talk about some of those here in just a moment as well. Some of those are actually targets. Some are doing what we call a blow and go, where you're just scanning in the field and doing some of your target acquisition, post-processing, as well as even some of the visual registration type things. But we'll talk more about that here on the next slide. So a little bit more about the project. We did about 300 scans for this particular area. We were on site for multiple weeks here. The data was all imported into Leica Cyclone, which is their proprietary software for registering and modeling and things of that sort. I did mention using a variety of different types of targets. Here on the screen you're actually seeing a jib. It's kind of like a boom lift, where we can actually put it out over objects that aren't trenches, for example. This happens to be over some ductwork that was blocking some line of sight for some stuff up above there. But utilizing fixed height targets that are, set on survey control. I mentioned the self-adhesive and paper targets as well. And then, of course, just some targets end up on magnetic bases or pipe bases that can be attached throughout the facility as well. So with that, on this next slide, we'll talk a little bit about the workflow. We do import the data and register it in Cyclone, as I mentioned. We then export the point clouds out as PTGs. We prefer PTGs for a variety of reasons. If anybody wants to get into that, certainly ask questions about that, but I won't bore you with that right now. And then once we have the PTGs, we actually can take that right into Edgewise. And Edgewise is a phenomenal product. It does some really neat things. We're going to talk about some of that here in just a minute. But continue on with the workflow. We utilized hard drives. We actually use USB 3.0, 7200 RPM external hard drives that we can pass around from guy to guy. The purpose there, one, you're not bogging down your local machine's hard drives, but also you eliminate any transfer time between different modelers and things of that sort. We can literally just unplug a drive, move it to the next guy, and go from there. And as you can see here, there were at any given time, we might have had up to 6 modelers working on the project at a time. There were a lot of, because of the age of this facility, there were a lot of custom or non-standard valves and flanges that we actually modeled and again did at the 350 to 400 LOD. So that is one thing that Edgewise can't do is the custom valves and flanges, but they certainly have a very robust ANSI library of standard features, and that'll come into play here a little bit. So certainly it was very helpful for us to utilize, but there were a few items in this particular job that we had to model custom. Okay, so a little bit about, the client in this case was interested in getting even down to a 1/2 inch piping and conduit throughout the facility. So what's great about Edgewise is we were able to auto extract a lot of that piping and conduit even down to that 1/2 inch. So this gave us a huge jump start on this project. We're going to talk a little bit more about that and how much time we felt it saved us and things of that sort. But probably our favorite tool, we call it the QA/QC tool. Very well designed. We use a lot of different software. This Edgewise is just one of our products that we utilize, and it has by far the best QA/QC tool. What it does is you have the ability to you run through, have it run through and do the auto extraction. It will then give you a list of all the pipes that it has found, and you can literally click on each pipe, and as you do that, it will take you to the view of that pipe, and you'll be looking straight down the pipe. You can actually then look at how well it fit to the cloud. This is a great tool for us, and then you can accept it, you can make changes, even making changes to it is very intuitive in this tool, so we love that. Another thing we find very useful is the ability to layer our pipes into their appropriate systems. So in this particular project, we actually did go through and identify all the systems for them, and by being able to put those on the different systems, and then actually, as we'll talk down in a minute here, getting into exporting it out into Revit, it automatically brings in those same layers into the Revit model so that there is some intelligence there. We did talk obviously a little bit about the ANSI standards there, which we'll talk about some more here as well. But then the other piece of this is the ability to connect pipe runs. So very much like the QA/QC tool, you can actually go through and it will show you where there's either missing data or areas that it didn't capture automatically, and you can actually look at it, verify, yes, this is in fact a pipe that should be connected, and you can have it connect those for you. And again, you can go through a QA/QC process with that. So it is a very good tool for that as well. So here on this next slide, talking about some of these the other things you should understand. If you haven't used point clouds, if you haven't used scan data, point clouds can be very large files. What's great is there's a lot of tips and tricks to dealing with that size. I mentioned the PTGs earlier, that file format that we like to use. One of the reasons is they are a little bit smaller files. They're also individual files, which allows us to do a lot of neat little things with it, which I'm not going to get into today. But another little tidbit here, it is very important to understand, in this case, our model was being delivered in Revit. It is important to understand in Revit what version they're using. So if they're using 2014, 2015, 2016, and now even 17's out, you want to make sure that it's getting modeled in that version. Unlike AutoCAD and other software, Revit likes to only use its current version. So it's, in our minds, it's a little bit of a limitation of Revit, but just something to be aware of here. And then on this particular project, schedule was also a challenge, as is most projects. They were interested in getting the model turned around quickly so that they could get that out to their contractors and things of that sort to bid on the project. So now getting into the good stuff here. We have been using Edgewise for quite a while. This particular project, we loved it, and one of the biggest things here was literally in 4 hours of processing time, and that's computer processing. That's not somebody sitting there doing this. This is, turn your computer on, hit the go button, and come back in 4 hours. And Edgewise was able to find over 76,000 pipes and conduits. That certainly gave us a very good head start on this particular project. As I mentioned, it's all hands-off time. We actually estimate, and I feel we're probably pretty conservative on this, we estimated a 60% time savings. And truthfully, I think that would have been higher on a lot of projects, except here we had a lot of custom flanges and valves and things of that sort that we still had to model. So most of our projects, we probably see a little bit higher time savings than this. As I mentioned, the QA/QC tool, that was a huge time saver on this project. I mean, it's just, if you haven't gotten the demo from these guys, you need to check it out because it's a very powerful tool. The other thing that we love about this is that it is a standalone software. A lot of our software, for example, if it imports into Revit, a lot of times you are utilizing one of your Revit licenses while you're using that software. Edgewise is not the same. Edgewise is truly a standalone software. So we can have one person working in Edgewise and they're not utilizing one of our Revit licenses or things of that sort. So I think that's very important to understand, especially when you start looking at the cost side of what Edgewise costs versus buying other licenses and things of that sort. So a couple of tips and tricks here. We do firmly believe that using a high quality scanner is important. It kind of goes back to the old adage of garbage in, garbage out. You do want nice, clean data. So I think, and there's also the right scanner for the right job. I mean, there's certainly some are better for this project and worse on others and things of that sort. So that is important to understand. In our case on this project, having the existing drawings from the client was important. Now, obviously, typically, and in this case, no different, the client's hiring us because they don't have good drawings. But the drawings that they do have are very helpful to us, particularly when we're trying to identify different systems and things of that sort. So, that is important to get, even if they aren't current or accurate. It certainly gives us a starting point. And then comprehensive scanning produces the best results. What we mean by that is we're trying to eliminate as many shadows as possible. You don't have to scan at your highest resolution, but if you can get as many angles and views and things of that sort as possible, it certainly does help to with everything on the modeling side and things of that sort. And then again, as I talked about tying to survey control, this really goes back to the fact of being able to, we can go back to any area within this plant and we can rescan it and import it right into our existing project very quickly, very easily, very accurately. And so that's part of the reason for that here. So I guess with that, I'm going to turn it back over to you guys.
All right, fantastic. Well, thank you. That was a great presentation. Cool project. Next up, we've got John Garner with Wadeland Geospatial. John, can you introduce yourself real quick, please?
Yeah, hi. Like I said, I'm John Garner. I've been with Wadeland Geospatial for 3 years. I'm the lead modeler, and roughly 6 years of modeling and survey experience. Anyway, that's kind of a quick on me.
Okay, thank you. And then we also have Rodney on this call. Rodney, can you give us a short introduction?
Yeah, founded Wadeland Geospatial in 2012. I have quite a bit of background in remote sensing, which is obviously acquiring information, the data on objects without touching them. And then I've been a professionally licensed surveyor in North Carolina, and have, I guess my first scan project was in 2002 with a laser scanner about the size, probably 3 by 4 feet. It was a large scanner, and things have obviously changed since then. The technology has gotten better, and we were excited about capturing 15,000 points in 30 minutes, and now we're capturing 50 million in 5 minutes. So things have changed.
Yeah, it's definitely been a cool market to be a part of. That's fantastic. Thank you, Rodney. All right, well, I'll let you guys just take it away with your presentation.
Sounds great. A little bit about Wadeland Geospatial. We're located in Raleigh, North Carolina. We're a non-traditional survey firm. With that being, we're not out surveying lot surveys or boundary surveys. We do a lot of different things, but mainly our focus is 3D laser scanning, 3D modeling. We do that above ground and actually underwater as well. We're a licensed survey firm. We're professionally licensed surveyors out collecting your information, setting your control. So we think that's very, very important to understand coordinate systems and understand the proper technique procedures in setting up your project right. We have extensive experience with power plants, industrial plants, pharmaceutical, biotech, manufacturing facilities. They all come with inherent issues. Some are dirty, some are extremely clean. So we kind of just take that in each project in consideration. So a little bit about this project. It's located here in North Carolina. It's a large coal fire facility. There were two operating units at this time. It was built in the 1960s, so you can imagine the age of some of the infrastructure, the pipe, and the design. The objective of the project was to duplicate ash disposal line for each unit. If one disposal line were to have a malfunction or be down, they want a duplicate line to route this fly ash out of the unit. So you can imagine they're routing this through an already congested area, 7 floors, around 2,000 linear feet to get to the main disposal line. It was a pretty intense engineering effort, to say the least, in 2-dimensional. I can't imagine doing this in 2-dimension, but 3-dimension offered a lot of benefits and advantages to them. We took the model to a level of detail of 300. The model was going to be utilized for pipe routing, equipment placement, and engineering, but they found that the model, we were on the front end of this for the scanning, so they found the model to be very useful for demolition bid packages that they needed to put out, which Ryan had touched on earlier, how they could really specifically detail the areas and the pieces of equipment and pipe that need to be removed and get specific bid estimates and reduce change orders on the front end on this project. The scope was around 36,000 square feet. Again, we had 7 floors of scanning on 2 different units, and we were utilizing a local coordinate system for this power plant. You can go on to the next slide. So some unique challenges. In general, we'll go into these a little more in the back one. So we're going to the coordinate system. They use some vibration of an operating plant, steam, and dust we encountered in our registration. This may, and for the project, it may not be unique because we had an aggressive schedule, and as most are. We were required to have 2 separate models. We were producing a CAD model and a Revit model. We had a couple of different vendors and engineers requiring the need for each of those models. Aligning those scans, we had scanned these units in 2013, different areas of these, and as the project progressed to another phase, they had some engineering changes and some scope changes, so we come back. We had to align those original scans with the previous scans, with our control as well as our models. As far as the project owner side, we had a couple of issues. As you can see, some of the employees at this plant have been there since the 70s and 80s. So we had an older mindset of a more experienced professionals, if you will, that they've done this work and engineered this work in the 2D environment forever. It's how they've done it. They've gone out to take field measurements forever as engineers and the owner side. And then you have a new group of professionals coming in, the more technology-driven, see the benefits of this. And so there's a little bit of a background clash going on with the project and the owner. And then as well, we had a piping vendor who was well-versed in Revit, well-versed in handling point clouds and designing in 3D environment, and an engineer in 2013 group that was selected that had very little experience in point cloud and 3D design. So as we move forward to this most recent project, we've seen a great advancement in the engineers' understanding of the 3D and the value they get from designing in 3D. So we've had a huge success story on this project. In the field collection, we utilize local plant coordinates. When they built this plant in the 50s, they had a coordinate system that's unique to this power plant. And they have a few monuments located around the plant. It's very difficult to get from those monuments into this congested power plant. We had to recover some of the old control, establish new control on the ground and at each level. Then we had target placements throughout the facility. We had a lot of opportunity to utilize the steel structures for magnet targets, for spheres, flat surface targets. We also had very limited accessibility to some of these areas due to the plant being in operation, just from a safety standpoint and a physical not able to get to standpoint. We utilize several types of scanners based on the project. You know, some scanners are good at long ranges, some scanners are good in short ranges and tight areas, and some scanners are good for just different applications. So we utilize a Faro, a Leica, and a Regal scanner. For this project, we felt the best scanner for this situation was a Faro scanner. We can scan in very tight quarters, you know, just a 2 feet by 2 feet box if we have to get into a tight area, which we had a lot of small areas that we would have to climb through, crawl up and down ladders. So the Faro was our best option for this project. These 2 units were around 150 scans each. It took 3 to 5 days per unit for scanning, so less than 2 weeks we were in and out. The plant was in operation, which is a good thing from their perspective. They want to minimize downtime because obviously the power plant running is making electricity and making money. So there were some maintenance activities taking place. We had steam. Steam is a enemy of laser scanning because we're obviously dealing with light. It reflects the light and causes false readings and returns. Some of the plant's piping would produce steam, and depending on the direction of the wind, so that offered us a challenge as far as this planning and working around steam. With an operating power plant, catwalks, stairwells, just anything at the power plant is vibrating. So we've come up with a few techniques. We have specialized tripods that help us deal with some of those vibration issues and just working around some of the plant's active areas. We had 7 levels to deal with, a lot of stairs and ladders, a lot of tying off, a lot of fall restraint situations we have to deal with. And the registration, we were held to a 1/4 of an inch accuracy, or I guess registration on this project. Our QC, we do an extensive QC process where we go out and do hand measurements between steel, randomly and systematic. We go throughout the whole project and come back and produce a QC report for the client. We were getting around an 1/8 of an inch registration on our point cloud and our model throughout this project, definitely less than a 1/4. So one of the unique challenges we have as far as this type of atmosphere is a lot of projects we can utilize automatic registration. So it would take flat planes, walls, floors, ceilings, and register a lot of this automatically. With this, in the power plant environment, it's completely irregular, a lot of corners, pipes, so it's mostly done manual on the back end as far as the registration goes. So from that point, once we get the clouds registered, we have a type mosaic point cloud. We export out into a format and send that off to our wonderful group of modelers, which John heads that up, and I'll hand that over to him and let him take over from here.
Okay, so we utilize some different software packages to create our models. Initially, bring everything in through February Scene to do our registration, and we export that out into we go straight into Edgewise from there. You know, we'll talk about that in a little more detail, but that covers a large portion of our model. We do any additional modeling in some other softwares that we use to cover anything that Edgewise isn't ready to handle. And from there we go into our Revit and CAD models. We utilize local SSDs for speed and performance, and external hard drives to transfer files around. This project was created by one modeler, and anyway, so we tied this into previously, you know, so as we already talked about previous controls and things like that, and so after we completed the model, we had to tie everything back into existing models. Okay. So roughly 75% of the pipes were found in this project using Edgewise auto extraction. We went through and we were able to do our layering for our CAD in Edgewise, in Edgewise. So we were also able to do any all our steel. There is an auto extraction feature for steel, not to the same extent that there is for piping, but there are some features. We weren't able to use it that often in this project. It kind of works in select cases where you have very repeatable patterns, but it does work from time to time. And we were able to create our cable trays and other miscellaneous objects throughout the project utilizing Edgewise. You know, here 98% of the module was created in Edgewise. You know, there are certain objects that, especially if you're going into a CAD project, if you creating certain things in Edgewise that may not go into a Revit family as well. It does very well into a CAD model. I can explain that in more detail if anybody has any questions. But a lot can be done in Edgewise. And then we also had some non-typical steel members. With this being an older plant, we had to utilize the standard editing feature in Edgewise to create those non-standard members. Okay. So for our final delivery, we brought everything together. We did this model in two separate sections. Brought them all together. So we were able to create a CAD model and a Revit model. And there are certain challenges to each. You know, CAD you can get by with certain things, and you can create more in if you're producing a CAD deliverable as opposed in Edgewise, or as opposed to a Revit deliverable. Oftentimes with Revit you have to go back and redo a few things, but that's typically electric panels, things like that. But your steel, your piping, you know, your really meat of your project gets covered in Edgewise. We also produce a recap file and a web share, which is was a really useful tool for a lot of our engineers. It's a really lightweight scan-by-scan view that somebody who may be an engineer who can come in and you don't want to deal with the full model, don't want to deal with the full point cloud, can look and measure things and gather information for an estimate or for just kind of basically a field visit without having to go out into the field. Next slide. Okay, so we really feel like Edgewise has saved us a ton of time, and I agree with Ryan on the 60% time savings. I went through this facility. We worked on about 3 years ago, and very comparable project, and which was done entirely in different software, to the one we created recently, this project here. And in comparing that, I was actually seeing more than 60% time savings. It's kind of an average, I think, of what I'm seeing from other projects. So you can kind of see the time I estimate that we save. So it looks, you can kind of see there how much time I think we saved. This biomedical facility that was done recently, actually it was last year, we had started off in our other software, and got to realize that it was going to take a lot longer than we originally thought. And so I'd been talking to Tim with Edgewise, or ClearEdge, and I think we talked for like a year or so, and then finally I was like, well, let's pull the trigger on this. I think it's time to get it, and it really helped us pull through, meet our schedule, meet our budgets, and Edgewise it's been an excellent tool. All right, next slide. So just a few tips. As a modeler, it's important to complete each section of the model, section by section. You don't want to leave things undone. You really want to get everything that you can done as you go through. Otherwise, you'll forget something, and it can cause just a lot of backtracking. A lot of works that way. Also, I utilize Navisworks for a project review, a QC review. I find that it's very helpful. You can bring in all your different models, because like I said, you're utilizing different software packages to create different elements of the entire model, along with the point cloud. So you can bring this all together. You can save separate views, and you can have a nice list of all the different items or checklist of things you need to go back and add to the model, or change in the model, whatever. Again, utilizing Edgewise to create as many objects as possible. I talked about, just to be a little more specific, with electric panels, I'll utilize, Edgewise doesn't have a feature for just generic boxes. So what I'll do is I'll create a wooden box, because it covers a lot of different sizes for electrical panels, and specifically going into CAD, but it also works going into Revit too. It's just a little bit more of a workaround, but it is nice to get as much done in Edgewise as you can, because it's a huge time saver as compared to other software packages. There's a little service department shout out. Their service department is great over at ClearEdge. Anytime I have any issues, anytime I get pretty, within a day, or usually it's within a few hours, if it's not too late in the day, I get a code response, and they've helped work through a few things, and so big shout out there to those guys. And as Ryan talked about the QA tool, I agree with a lot of what he says, and just something else to kind of add to that, as you go through a project, you have to examine your registration and make sure all your clouds are tied together, and it's really, I've actually found this to be a great way to check your cohesion of your point cloud, to make sure everything ties together properly, because you can quickly go through you can go through every pipe that Edgewise has created, and you'll quickly see if you have issues with your registration. So it's kind of something that it's not advertised or that it's supposed to do, but it's something that find really nice. Okay.
All right. Well, fantastic. Thank you, John and Rodney. That was a great presentation. Well, cool. Want to just encourage everybody. Feel free to please input your questions into the chat window. And now that we're over, we can start talking through some of these questions and ask our experts. But even now, as we go through some of these questions, please continue. Just put in any questions that you have into the chat window, and we should be able to get to a fair number of them. So first question I've got for both of you guys, and whoever wants to take this first, feel free. But just in general, do you have any tips for communicating the value of laser scanning to a plant owner or operator?
You know, that's a great question. Do I have any tips? I mean, I think, you know, what I would say, and I guess I'll go back to a project that we recently did where we had talked to the client a couple years prior about doing some scanning for them, and they were, you know, unsure if they wanted to do it at the time, things of that sort. Well, fast forward a couple years, and they brought us back in and asked us to come in and look at it, and they were walking us through the plant, and the guys that were giving us the walkthrough were asking us, hey, can you guys do this? Can you capture this? Can you do this? And you know, we said, yeah, yep, we can do that. And at one point, one of the guys actually said to us, he turned to us and said, man, I wish we would have known about you guys a couple years ago. You know, we spent $400,000 on change orders related to these issues. And I was amazed by the fact that they had that kind of the change orders, and truthfully, I feel that laser scanning would have minimized, you know, I won't say all of it, but a lot of that that cost for them. In fact, we certainly would have paid for ourselves over and over again had they got us in at the beginning of that project. So I guess to directly answer your question, you know, it is always hard to get companies to spend money up front where they say, geez, we don't really need to spend this money, but it certainly will reduce costs down the road. And we as a laser scanning firm struggle with this a little bit in being able to say, well, this is going to save you X amount or X percentage on every project you do. And the reason for that, the only way we could truly get that number is if we ran the project parallel to each other, one with scanning and one without, and obviously that's not possible. So there is that tough sell that people have to go to their managers or their companies and say, we need to spend, you know, $50,000 up front so that we save $100,000 on the back end. That's a little bit of a tough sell, but in reality, you know, that is a practicality. I don't know, John, do you have any other thoughts there?
Rodney, I'll jump in on a couple. A quick sell for a couple of our clients has been they have very minimized downtime. You know, every minute they're offline is money. And so one project we recently completed was going in to scan a huge pipe bridge, and they had 3D designs of their new pipe routes, and they had 1 week to get this in, 1 week of an outage. And so we overlaid, took their 3D design and clashed it against our point cloud. It was a real quick scan, 2 or 3 day scan, come back, register the point cloud, take their 3D design, and then in hours we identified over 20 conflicts or clashes that they were going to have to manage and pre-plan for. And the contractor said immediately that if we had to do that in the field on the fly, we're looking at a month delay. They did extend their 1 week outage to I think it was 8 days. And so there's so many of those success stories that I would take up the rest of the day that eventually I think you'll see the benefit. It just takes a couple of those really heartburn situations like Ryan mentioned to be a firm believer or some successes like we've experienced.
Rodney, I guess I'm going to jump back in. We had an exact situation just like that. Clients, first time ever using point clouds, they were real hesitant about getting laser scanning involved. It was a big project for them, and they thought maybe this isn't the right one. They had our data for 3 days, and the guy literally called up and said, "Oh my gosh, you guys more than paid for yourselves." You know, here they were installing this structural steel, kind of superstructure over top of an existing structure, and you know, and like you said, we get that over and over where people use it and then they realize how much money it did save them. So you could go over those type of stories again and again.
That's fantastic. And maybe that's kind of the key to selling people, is just building up a repertoire of stories, real life stories to communicate. Ryan, let me ask you another question. Here's a question from Greg Schneider. Why do you like PTG format? Can you elaborate a little bit there?
Yep, great question. So one of the things I mentioned briefly was the fact that they are a little bit lighter weight. There's actually, for our workflow, you know, PTGs, PTSs, PTXs, all of those file formats work great. What we like about the PTGs is being a little bit smaller, but more importantly, we like that the files, it's individual scan files. So basically for every scan we have, it gives us its own file. Now they're all registered together, so if you bring them in one at a time, they're obviously going to fall into the right place, if you will. But for our workflow, it does a lot of different things. So one of the things we'll do is, say we're going into an Autodesk product, we need to index those point clouds using recap. And when you do that, you have the ability, we can export PTGs out, and as those are exporting out, we can start importing those into recap and already start indexing the clouds. And so I guess it's sort of like that idea of, are you doing, you know, batch processing or continuous processing? We like the PTGs because you can do the continuous processing with them. And then that even, a lot of our clients get our data, we upload it to them. We certainly deliver on hard drives as well, but some clients want it a little quicker and they want to be able to just get it. So we can start uploading the PTGs or RCSs, you know, essentially one at a time as they come off the line. And so those are some of the reasons. You also get into, you know, if I export a PTS, for example, overnight, and I'm doing a power plant, and I get one file, so I could get to 98% completion, and my computer crashes, and I'm back to square one. If I use PTGs, I can see where I lost it. I can go back to that point. I can pick up from there and move on. So for our purposes, it's really more of just keeping the process moving along and biting off little pieces versus biting off one big piece. It also gets into being able to, when you're in some of these software packages, you can turn off or turn on certain clouds that you want to use. So that's a way to enhance your performance of the point cloud by only limiting, you know, points to the areas you want. And there's other ways to do that as well, but those are just some of the reasons why we like the PTGs. So.
Yeah, I've got to agree with you. It's one of Leica's best kept secrets. Very few people know about it, but it's a great file format, one of the best ones out there. Here's an interesting question. Have either of you guys had to scan in a clean room type space with containment? How would you scan within a localized containment like a bio bubble while maintaining line of sight to targets?
Yep. Do you want me to grab that, Rodney or John, or do you guys want to chat on that one?
Matters not. We've been in a clean room for 3 days. 3 of the last 5 days I've been in a clean room. So you have some unique challenges in the clean room, including your equipment. So we have some dedicated equipment just for biopharmaceutical facilities. Some of these areas that if you go in, you can utilize targetless registration. So if we go into a tank or an area that we want to validate a tank or do some inspection on a tank, whether it be in a clean room or any environment, we can put the scanner in and scan And if it's just a tank, we don't have to do any registration. So if it's only one scan, utilizing that. But otherwise, in the clean room, we have some specific issues we have to deal with as far as our equipment and how we operate. But it works quite well, and we've had several successful projects in clean rooms.
And I'll just back on that too. You know, we've had the same kind of experience. It can add some nuances if you've got, you know, plastic around and things of that sort, particularly too if you're in hospital environments and they won't, you know, allow you to have, you know, any line of sight. I mean, there are certainly challenges to it, but it can be done, and it really is just a case-by-case basis as to, you know, how large of an area is quarantined off and things of that sort.
The biggest challenge is stainless steel and reflectivity of the laser. So that's probably your biggest challenge in those areas, and we come up with some ways of handling that without having to compromise the you know, the quality QA process and GMPs that they employ.
Okay, I know we're bumping up against the hour here, so I'm going to ask two more fairly short questions, and then I think that's about all we have time for. On the coal-fired plant, was Edgewise used to successfully extract the steel cross bracing?
It was. I had to modify the standards some because it's like I said, it's an older facility, so not all that was in there, but it did. And that's, again, with the auto extraction of Edgewise, it's not, for the steel members, it's not the same as the pipe. The pipe, you run it through in the beginning and it captures everything you can find. With the steel, it's a little more manual, but it's less manual than it is in other softwares. But you know, you highlight a member and it extracts it. So yeah, so if there's a member that you can't, that you're not getting from the tool, you simply go to the standard editor, you plug in the dimensions that you need, and then it'll find it. So kind of keeping that up to date.
Okay. Yeah, it's an assistive modeling technology where you point at something and it will extract, and it's all based on standards, and it's a modifiable standard table that you can use. So let me ask both of you guys, have you guys used any of this type of technology to support a 4D schedule, tying a model data to a schedule to animate the work sequence?
Yes, we have. We actually do that quite a bit. We actually have a general contractor that we work with. We literally scanned their project 3 years ago, and almost on a daily basis we get calls from them, you know, hey, can you extract this out, can you give us this, and some of what we've been doing for them here recently actually is just that they're trying to look at a piece of their construction process and figure out how they're going to do it, and we've given them some 4D animations showing them that construction cycle and things of that sort. But we are doing that more and more with our clients.
Yeah, and this Rodney here, we actually have some projects that are ongoing where we scan, the last one was a large retention wall where we scan it actually at some point on a daily basis, and you can kind of model that and animate what's going on with that wall, where things are moving, how much they're moving, and important to the owner, they want to know if it's moving, but also when it's not moving, and document that to some level so they can continue the progress. So that's a very interesting project. You're watching kind of a three-dimensional project, watch it progress and see the wall move. It's interesting.
Yeah, definitely.
And I was just looking. We do have an example of some of the 4D stuff on our website. If someone wants to check that out, it's under our construction applications.
Fantastic. Very cool. Well, I apologize for running a little bit over, but this is all fantastic information. I appreciate it, guys. So with that, we're going to wrap up the webinar. Thanks for joining us, and we'll see you next time.